Okay, close your Chromebook. Thank you, sir. Alright, so today we're talking about fractions and mixed numbers and how we use those mixed numbers when we add, subtract, multiply, and divide. The first examples they give you are graphing a number or a fraction on a number line. We're not going to do these. We're skipping right over these, okay? I feel like you guys should know how to do that and should have a good grasp on whether a half or a fourth or 3/4 is bigger, okay? So we're skipping that. Next, we're going to multiply and divide with mixed numbers or whole numbers. When we multiply or divide, and this is in your notes right here, we're going to take a mixed number, turn it into an improper fraction before we multiply and divide. So this example is right down below. In order to turn those mixed numbers into improper fractions, what do we have to do? Multiply and add. What am I multiplying? 2 times 2 plus 1 gives me what? And what does that have to go over the top of? 2. And I am dividing that by 1/2. Okay, this is what I call the popcorn method, simply because it looks like a piece of popcorn after we multiply and add. I know, right? That's awesome. So now we are ready to work that out. In order to divide a fraction, what do I have to do, Blake? I might have said it right. Well, I didn't hear you. We do have to multiply after we do what to the second fraction? Flip it. We flip and multiply. Okay? Say it like you're saying something bad. How do you divide fractions? You flip and multiply. Right? That's all you got to remember. We divide fractions, you flip and multiply. Okay? Flip and multiply. So we're going to flip that second fraction, and when we flip it over, we end up with 2 over 1. So I have 5 over 2. Now I'm multiplying 2 over 1. Is there anything I can cross-cancel before I multiply? Let's cross-cancel our 2's. If we cross-cancel our 2's, they both become what? 1's. Then we end up with 5 times 1. Well, they didn't cross-cancel. 5 times 1. And 1 times 1, which gives me the whole number of 5. If you do not cross-cancel, you end up with 10 over 2. We divide that, and you end up with 5. Mikey, you with us? Mm-hmm. Okay, what do I need to go back over to get you with me? Okay. So that's example 1. Hopefully you wrote down some notes. Example 2 says we're going to multiply 10 by 7/8. What is underneath that 10? A 1. We have a 10 over 1, and we're multiplying that by 7/8. Morning, Miss Todd. It's all right. There is a set of notes there. There are just 23 examples with this section, so I'm like, we're getting started right now. Okay. Don't worry about being late. No worries. Okay. So 10 over 1, because that is a whole number. So we put that over a 1. We turn it into a fraction. If I have 10 over 1 times 7 over 8, is there anything I can cross-cancel before I multiply? What can I cross-cancel, Mikey? The 7 and the 1 cannot be cross-canceled. Those are both prime numbers. So what's your other guess? The 10 and the 8. That's exactly right. What can I take out of both the 10 and an 8? What are they both divisible by? 2. If I divide 10 by 2, this could become a... And if I divide 8 by 2, this becomes a... Now I end up with what? $35 over that. Nope, because we cross-canceled. They did not cross-cancel in this example, but we did, so we don't have to reduce. Huh? 4. 35 over 4. Can 35 over 4 be turned back into a mixed number? Not just probably, yes, absolutely. How do I turn 35 over 4 back into a mixed number? By dividing it. 35 in the box, 4 outside the box. Got that, Blake? Okay. Our next example gives us 2 mixed numbers that we're going to multiply. In order to multiply mixed numbers, first we have to turn them into improper fractions. So I'm going to multiply 16 over 5. I also have to do that method to this as well. 2 times 4 plus 3. I am multiplying these, so do I flip anything? No, I do not. Is there anything I can cross-cancel before I go any further? Okay, what can I cross-cancel? The 16 and the 4. What does the 16 become if I divide it by 4? A 4. What does the 4 become? A 1. What is 4 times 11? And what is 5 times 1? So I end up with 44/5, which can be turned back into that mixed number by dividing, writing our remainder over the top of our divisor. So that is multiplying and dividing fractions, okay? Oh, just kidding. We got 2 more examples, I think. So we're on the back side of your notes now, if you would like to write some of these down. This one says we're dividing. What do I have to do first before I can divide these 2 numbers? Put a 1 under my 7. So that becomes 7 over 1. Now, how do I divide fractions, Blake? Like we just talked about this. I really thought you would remember that. Flip and multiply, right? Flip and multiply. If I'm dividing these fractions, I put a 1 underneath that 7, and then I flip it over and I multiply. So I have 4/9 times 1/7. Can I cross-cancel anything in this equation? No, I cannot. There is nothing I can reduce here. So then to multiply my fractions, I just multiply straight across. What is 4 times 1? What is 9 times 7? Can that be reduced? I got some. Let me tell you a little secret. If there is nothing that can cross-cancel out of your fractions to begin with, you are in lowest terms. There is no way that that can reduce. Okay? So as long as you have cross-canceled everything out of your fractions before you multiply, then you are in lowest terms. You don't have to worry about reducing it. You bet. That's what I like to hear. You should probably write that down. That might come in handy on a test. Oh, good. That's what I like to hear. It's going to be a great day. Attaboy. right, now we have two mixed numbers. Two mixed numbers that we're dividing. Before I can divide mixed numbers, I have to do what? Turn them into improper fractions. So what does this become? 3 times 1 is 21, plus 2 is 23, so 23 over 7. My second fraction, I'm going to also multiply and add 2 times 14, plus 3, 31. 31 over 14. Now I'm going to divide these two fractions. In order to divide these fractions, Blake, what do I have to do? Flip and multiply. Oh my. Before I multiply straight across, is there something I can cross cancel? The 7 and the 14. The 7 would become a 1, because we can take a 7 out of both 7 and 14. And the 14 would become a 2. So now it gets a little easier because we're just taking 23 times 2 and 31 times 1, which is 46 over 31. 46 is bigger than 31, so I can turn that back into a mixed number.
How did we get 31?
We flipped.
Oh, maybe I have.
Okay.
Oh, I had it right. I just when I wrote it on the bottom, I put 13 instead of 31.
Happens.
Initially, I had it right.
Number dyslexia, it's a real thing.
Okay.
Questions about that one, back row? Mikey? Okay, I will give you a sec.
Okay, that makes a lot more good sense right there.
Yay! Okay, let's look at it. Oh, now we're talking about adding and subtracting. Why do I have one more example there, I wonder? Okay, well, maybe we'll come back to that later in our PowerPoint. I don't know why I put that there. Anyway, we're adding and subtracting mixed numbers. Okay, multiplying and dividing was the easy part. Okay, adding and subtracting is where it gets a little more difficult. It's fine though, because we're going to work it out. So we know that when we're dealing with fractions, what do we need in order to add and subtract fractions? Common denominators, absolutely. So first we're going to add or subtract our fraction part. Then we're going to deal with our whole numbers and our mixed numbers, okay? We're not turning them into improper fractions anymore. Okay, so first we're going to deal with our fractions, then we'll deal with our whole numbers. So when we have 12 and 5/12, and we're adding 4 and 1/6, what would be our common denominator? 12. So do I have to change my first mixed number? Nope. Am I changing my second one? Yes. What do I take 6 times to get to 12? So I also have to do whatever I do to the bottom, I also have to do to the top. So that becomes 2/12. Now I deal with my fractions first. I have 5/12 plus 2/12, which is what? 7/12. And I have 12 plus 4, which is 16. Just like that, we're done. Got that wrote down? Okay, moving on. This time we have 3 numbers that we're adding. You might want to rewrite this over on the side of your notes or something up and down, because I have it written in there sideways and it's kind of crazy. So we have 3 numbers. We have the whole number 12. We have 3 6/7, and we have 2 1/5. When we look for that common denominator, is there anything next to that 12 that we have to consider? Nope. It's just a whole number. We can let it hang out on its own. So our other 2 fractions are 6/7 and 1/5. What is our common denominator between 7 and 5? 35. So I'm going to multiply each of those. My 12 is still going to stay 12. What do I multiply 7 by to get to 35? So whatever I do to the bottom, I also have to do to the top. So that becomes 30 35ths. And the bottom, I multiply 7 times 5 to get 35. And so I also have to take that times the top. So that becomes 7 35ths. Now I add those together. I have 30 and I have 7. So how many 35ths do I have altogether? 37 35ths. Now I come back to my whole numbers and I add those all together. I have 12, 3, and 2. When I add 12, 3, and 2, I end up with 17. This is where it gets super fun, okay? So I have an improper fraction as my fraction. I have to turn that into a mixed number and then combine that with my whole number. So 37 35ths is the same as what? If we're just looking at this fraction right here and I want to turn it into a mixed number, it becomes what? Morning.
Not my fault.
Okay. 35 goes into 37 how many times?
17.
Just once. Just once with how many left over? So it would be 1 2/35. We're on the back side working out some examples. Now I also have my whole number 17 hanging out down here. So I have to add that on. There's nothing to add to my fraction. My fraction can stay 2/35. And 17 plus this 1 is. So my final answer is 18 2/35. Yep. It's just like an extra step where we have to take that improper fraction and carry it over to our whole number. Okay, let's look at our next one. Ooh, fun. Now we get to subtract. Sometimes when we subtract, we have to borrow. Okay? It is fun, Blake. It is so fun. Ew. So I have a 9 1/5 and 8 6/25. The first thing I need to do is find a common denominator. Between 5 and 25, what's my common denominator going to be? 25. So my bottom stays the same. My top becomes what? 5 25ths, because I take 5 times 5 to make the common denominator 25. And whatever I do to the bottom, I have to do to the top. Now I have 5 25ths and I'm taking away 6 25ths. Can I do that? No, because 5 is less than 6. So we have to borrow. Okay? When we borrow in a mixed number, we look at our whole number and I say, well, I'm going to borrow one there and that becomes an 8. That's normal. That's just what we do anytime we borrow, right? But in order to add it on to my fraction over here, I have to think about what that 1 that I borrowed looks like. Okay, so we're looking at our denominator of 25. If I wanted to write a fraction that equaled 1 with a denominator of 25, what would it be? So close. We want it to reduce down to 1. 25. So anytime you borrow a whole 1 from your whole numbers, it's going to become whatever your denominator is over the top of itself. Okay, we're looking for that whole 1 that we borrowed. Then we have to add on what we already have here. So 5 plus 25 is 30 25ths. Now that I have 30 25ths, can I take 6 away? Absolutely. My number is bigger than my bottom number. So I can take that away and subtract. Okay, let me catch up on my notes real quick. So when I subtract 6 25ths from 30 25ths, what do I end up with? 24 25ths. And I have 8 minus 8. So that's not going to leave me any whole numbers left. So my answer then is 24 25ths. Lots of steps, okay? Borrowing from that whole number onto our fractions is going to be the hardest part of today's assignment. Huh?
That makes it be the answer, 24 25.
Uh-huh.
Is it negative though because you subtracted it or no?
No. Nope. It is not negative.
So I'm assuming if the numbers were negative, it would look different.
Yes. Guess what? We're going to get to some of those.
Okay,
No.
yay. It would look like this. But I mean like when you're adding and subtracting. Because I get what it looks like when you're multiplying or dividing.
Right.
Oh, like down here. Okay.
Like down on that, yeah.
Okay.
Yeah.
This session, I go to the bathroom.
Hi, if you don't need to hang out for notes, you go to the bathroom. Sure. Fine. Sounds great.
I've had cases over.
Well, then you probably should have came in and done that before you came to class.
Gotta bother you.
Okay. So our next example says we have the whole number 25 and we're subtracting a mixed number away from it. So 25 minus 10 and 2/9. First, I'm going to rewrite my problem up and down because I am a firm believer when we add and subtract, it probably should be up and down to get that done. Okay? Is there a fraction for me to take my fraction away from? No. So I have to borrow again. I have to put a fraction there. If I'm borrowing from this 25, it becomes a 24. And my fraction that I'm going to put here to subtract from would be what? Remember, we need it to equal 1 and have a common denominator.
24 over 20. Oh. How'd we get 9?
Because I'm subtracting 2/9. So my fraction that I'm working with down here, I can just take this denominator and make it this denominator right here. right? That's the cool thing about ones, is it can just be any number over any number. So you can just pick whatever number you got here that you're working with. So what is 9 take away 2? 7. So I end up with 7/9. And then I have 24 take away 10, 14. So 14 and 7/9 becomes my answer.
Okay. Sorry.
No, it's okay.
I'm
It's
not
all
being
right.
helpful.
You are being very helpful because I think the people in the back don't ask questions. So when you ask questions,
Okay.
it's a great idea.
But whatever number that you have to. Okay, so like it has to be the whole number beside it that you borrow from.
Right.
But the common denominator can be from any number below it. Or,
That is
right?
just truck show between.
The denominator can match any number. Yeah. If
Okay.
you're borrowing from that whole number, like your
Okay.
your
Okay.
fraction can be any number. Okay, so the next two examples are fairly simple. They just say write this mixed number as, or write this improper fraction as a mixed number. How do I do that? What do I have to do, Mason, to write?
Mix them up.
Huh?
Mix them up.
Nope, not so much. Or we could say we're going to divide. So top number goes in the box, bottom number goes outside the box. We're dividing these numbers to turn them into mixed numbers. So I have 37 divided by 8. That's going to give me what? 4. What do I have when I subtract? Mason, pay attention. What's 37 minus 32? 5. So I end up with 5 over the top of what? What number is my denominator here? 8. It stays 8. So 4 and 5/8 is not my final answer. Why? Nope. Because it's a negative. There was a negative in front of my fraction. So my actual answer is going to be -4 and 5/8. The next one, I have 46 over 5 that is a negative. What goes inside my box? And 5 outside my box. That'll go in there how many times? And how many left over? So 9 and 1/5. But 9 and 1/5 is not my final answer because it's a negative. There is a negative sign in front of there. So we're going to divide. What do I have to do to divide these numbers?
Mason.
What do I have to do to divide these numbers?
Ask him.
Why?
Just this time, ask Mason.
Just ask Mason?
Yeah, I want to know if he knows it.
Oh, okay. Mikey, what do I have to do to divide?
Flip your last numbers, but first you gotta do the thing with the whole number.
First, you got to do the thing, and then we're going to flip. I agree. So first, we got to do this thing where we multiply and add. So that becomes what? 13 over 3. And I'm dividing by that -1/2. Notice we have a negative this time. In order to divide, I have to flip. So I'm flipping over my -1/2, and that becomes a -2 over 1. Is there anything I can cross cancel out of this before I multiply? Nope, there is nothing I can cross cancel. Multiply straight across. 13 times 2 is? 3 times 1 is?
3
Positive or negative?
going to be a
Negative, because I have one positive number and one negative number, so that's going to give me a negative. I have an improper fraction. Let's turn that back into a mixed number. It's going to become what? 3 will go into 26 how many times? I think more.
8.
8. With how many left over? 2. So negative 8 2/3. Got her. Good. Now we're going to add with a negative number.
Can we just switch it and put negative 12 on top?
Yes, we can.
Because that solves the problem, right?
Right, as long as you put your answer as a negative, yeah. Yep. What is my common denominator between?
40.
Between 3 and 4?
Oh.
12. So we're going to use 12 as our common denominator. When I multiply, what do I multiply 4 times to get to 12? So whatever I do to the bottom, also have to do to the top.
And since it's negative, we actually subtract, right?
Right. Yep.
Not if you put the negative 12 and 3/4 on top.
Right? So if you put, okay, so what Mrs. Todd is saying is that this problem is going to be so much easier if we put our big number on top. All through grade school, you're told to put your big number on top, right? So put your big number on top. And then subtract. Just remember that our bigger number is a negative. So when we're done, our answer is going to be negative. So if we put that 12 and 9/12 on top, and our 6 and 8/12 on the bottom, you don't have to borrow anything because we're taking 9 or 8 away from 9 and 6 away from 12.
6, 1, 12.
Oh, nice job reading the screen. Too bad you didn't work it out on your
I
paper.
didn't write the screen.
Oh, you didn't?
I didn't see that part down there.
Okay. Okay. Let's work out that last one that I put on there for some reason and didn't ever work out. 3 1/5 times 2 3/4.
Good.
Over at the bottom of the first column. Okay, so Valeria says this one's going to be 16/5 after we multiply and add.
Oh, crap. Okay.
What about the next one, Mikey?
What did Valeria say? Okay,
16/5. 11/4. When I multiply, I can cross cancel. The 16 and the 4. The 16 becomes a.
Skip that step.
It's all right. That just means you have to reduce when you're done.
Well, that was a really big number.
So when I multiply straight across, I end up with 44/5. Does that reduce down? Can I turn that into a mixed number? Yes. 8 times with 4 left over.
I think I would have eventually gotten to there the route I was going. It's a really big
Right? A
number.
big number. Big numbers are a lot scarier than little numbers. It's on the front. That's where I'd seen it before. I just put it on there twice. Okay, questions, comments, concerns. There are 11 problems on your online assignment that are going to deal with these exact things.
Oh my.
Okay, 11 problems. Yep. Your test is going to be next Friday, the 16th, over this chapter.
Okay.
All assignments must be turned in by that Monday, the 19th.
I'm gonna try to get my paper ones turned in today.
Perfect.
At least 100 and some point.